Hello everyone, I'm Frank and welcome to Frank Puzzles, and this is today's hard level difficulty puzzle, and it's called Big Latin Y Squared by Coctuslaw, or Slav, sorry. And here are the rules. We have Latin square, where we need to place the digits 1 through 9 exactly once in each row and column. There are no designated 9-cell regions. And that's typical Latin square rule. We also have yin-yang shading, where we need to shade some cells so that all shaded cells are orthogonally connected and all unshaded cells are orthogonally connected, and no 2x2 area is entirely shaded or entirely unshaded. And this is a valid example of a yin-yang shading, because what does it mean to be orthogonally connected? That means you can go from any cell in the region to any other cell in the region just by going through edges, all while staying within the region. So to go from this shaded cell to this shaded cell, you can go all the way this way, and you just go through edges, all while being in the shaded region. And the same is with the unshaded region, right? What is not a valid region is something like this, or a valid shading, I should say, because this cell cannot get to any other cell in the shaded region just by going through edges while staying within the shaded region, and these unshaded cells can't get to the other unshaded cells because they would have to go through a corner or go through the shaded part, which is not allowed. This is not a valid shading either because you have a 2x2 area that is unshaded. And that's an example of how yin-yang shading works. We also have YY cages, where within each cage, the sum of the shaded digits equals the sum of the unshaded digits. Digits may repeat within a cage. So you could have something like, I don't know, 8 and 9, and then you have 9, 1, 7. And this would work as a YY cage because the shaded part 17 adds up to 17, and the unshaded part adds up to the same sum. And that's an example of how YY cages work. And finally, we have clones, where the corner cells with the gray diamonds, which are just these two cells, contain the same digit. So these must be the same digit here. Maybe they're 3. Maybe it's a 3 in the corner. I don't know. Anyways, those are all the rules. If you'd like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. Okay, let's look. So the thing that I'm looking for is cages, which are completely on the edge. And we have 2 of them. So there has to be some breakup of shaded and unshaded cells in every cage. Because of that, we know, and you know that if you can only change shading twice on the edge of the Sudoku grid. And the reason why you know that is, say you tried to change more than twice, right? It could change 0 times too, actually. You could have completely unshaded, you could have one shading completely on the side, but you could only change at most twice, I should say. So say you had this shaded here like blue, then switch to green, then switch to blue, then switch to green, right? You can't have odd numbers of switching for the shading. You always have to have even numbers because you always have to swap back, right? Well, the problem is, how do you orthogonally connect the green cells without breaking the blue cells into multiple regions? And the answer is you can't. And it's the same thing for the blue region, right? To be orthogonally connect that, you're going to necessarily have to break the green region into multiple regions. That's why you can only swap twice in on the edge of a puzzle for yin-yang shading. So we know it has to swap here, and it has to swap here to have the YY cages sum, where the shaded 8 parts sum to equal to the unshaded parts. So this has to be all the same shading. It switches somewhere here, and then this is all the same shading. Therefore, this is a 2x2 area that's all blue, so this must be green. 2x2 area that's all blue, this must be green. 2x2 area that's all green, so this must be blue. 2x2 area that's all green, so that must be blue. Okay, so these 3 digits must sum up to what this digit is. It could be 1 to 1 at minimum. So this is at least 4. So it's the same for every 2x2 box that has 3 of one shade, one color, and 1 of another. Okay. These are the same digit. One of these at least is green. One of these is at least green. One of these is at least green. One of these is at least blue. One of these is at least blue. Okay. You could have... In the corner can only be 1 through 7. Because you could have 7, 1, 1 twice. And these these ones here can be 1, 6. To add up to the 9 here. Again, 1 through 7, 1 through 6, 1 through 6, 1 through 7, 1 through 6, 1 through 6. Okay. Say you had 711 here, which is the maximum this digit could be. And then this is 711. I don't think that works. Because then none of these could be 1. Oh, you could. Never mind. That could actually work. um... Hmm. Oh, interesting. That doesn't tell us very much. Hmm. Hmm. Okay, what else do we have? This could be 1 blue and 1 green, or 1 green and 1 blue, because you can repeat in cages. You could have something like 1, 2, 3, 1. That would be kind of problematic, though. Say you did have like 1, 2, 3, 1. Well, okay, 1, 2, 3, 2, or something like that. That means this is at minimum 4 and 5, right? This would have to be minimum 4, 5, 6, 7. And there's no combination. So 4, 5, 6, 7 adds up to yeah, so that's interesting. What happens if these are essentially the digits 1 through 7? If that's the case, these have to be 8 and 9. Same with this, right? So the question is, can it ever be 3 digits can it be 4 greens and a blue here? Or 4 blues and a green here? I think the answer is no. Because 1 through 7, so 1 through 7 adds up to 28. 1 through 7 adds up to 28. If you had 4 greens and 1 blue, this would be at minimum 1. Therefore, this would have to be at maximum 8 in value. 28 minus 8 is 20. So then one of these digits, one of these pairs then would have to at least add up to 10. And obviously you can't have a single digit be 10. So this does have to be both blue. This does have to be both green because of that, right? Because we know that these 4 can only have to be less. So these 3 by themselves have to be less than 9. So this is these 4 plus these 2 have to be less than 17, right? So then these, that would mean since these are less than 17, these 2 can only be 3 at least. So these have to add up to at most 14. Okay. Which means this is at least 14 here. Because 27 digits at minimum adds up to 28. 28 minus 14. And yeah, so this is the same. 28 minus 14. So this is only 2 digits. Ooh. So this is 14 at minimum. Sorry, at maximum. Which means this must be at minimum 14. This is at minimum 14. Which means this must be at minimum 14. And this is at minimum 14. Which is... if they try to maximize it, then there's no way that can work. So this has to be 14. This has to be 14. And this must be 3. So then these add up to 8 and 9. Same with this. So you have 8 and 9. This adds up to 14. This has to be 1, 2 as a pair. And this is just the way because of how this works, right? This can only be 14 going that way. This can be 14 going that way. It must be 5, 9, and 6, 8. So this is 5, 6. This is 8, 9. 5, 6, 8, 9. This has to be 14. So this is 8, 9 here. This is 8, 9 here. And same here. This is 8, 9, and 8, 9. This must be 1 through 7. This cannot be 5, 6, or 7. This is 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1 through 7 here. 1 through 7 here. Remaining digits. So this is, again, 1, 2 here. 1, 2 here. That eliminates 1 and 2 in the rest of the row 1 and row 9. Okay. Rest of row 9 then and row 1 have to be 3 through 9. No 7 here. 3 through 9. No 7 here. Rest of column 2 and column 8 cannot be 1, 2, 8, or 9, so 3 through 7. Okay. So for these, eight and 9 cannot add up with another digit to add up to a single digit. So these have to be the same, and they add up to the 8 or 9. Same with this. These have to be the same and add up to 8 or 9. Therefore, this is a 2x2 area that's blue. This must be green. 2x2 area that has 3 green, so this must be blue. This could be 8 or 9, so we don't know about this. The reason why we know about these is neither of these could be 8 or 9. So you can't have one with whatever. So these two add up to this. It must be 3, 4, or 3, 5? Or 4, 5. No, not 3, 4. So 3, 6. So this can't be 7. 3, 6, 4, 5. Sorry, 3, 6, 3, 5, 3, 6, or 4, 5 here. And this is the same. So 1 of 5 or 6 is here. 1 of 5 or 6 is here, so this cannot be 5 or 6. Same with these. This cannot be 5 or 6. This is kind of symmetrical, actually, a little bit here. We have green and green here. That's interesting. One of these has to be green. Because you can't have two blues here because this 2x2 area would then be all blue. So, we only have one green and one blue here. Which means 3 of the digits must add up to the other digit. So this can't be 7, 8, or 9. This is 1 through 6. This can't be 8 or 9, but it could be the blue if it's 6 or 7. Interesting. So these digits are 1 through 7. And 7 cannot be here. This can't be... Oh. One of these is blue as 6 or 7 because this is 8, 9. This is 8, 9. Same with this is 8, 9, 8, 9. So this is 1 through 7. Interesting. So this must be 6 or 7 to add up to. So this has to be 3 or 4. This has to be 1 or 2. And we have another 1 or 2 here, which eliminates 1 and 2 in the rest of the column. This can't... Yeah, so these two must add up to this one. So these are both blue. These two must add up to this one because of the same thing. Neither of these are 8 or 9. So these are both green. Which forces this to be blue and this to be green. That forces this to be blue because of the 2x2 area. Also, another thing about yin-yang shading is you can't have two diagonals of opposite colors crossing each other. Because if you did, how would you connect the blue orthogonally to each other without splitting the green region? You could not. And the same with the green region. So therefore, this has to be blue. So this cannot contain 7, because 7 only adds up with 1 or 2 to add up to 9. So this can't be 7. This is also, this could be 1 or 2. So this is fine being 1 or 2, but this cannot be 1 or 2 because one of these is... This has to be a 1, 2... So this must be 1, 2, or 6, 7 adding up. And we know the 1 and 2 are here. But that's specifically for this one. One of these has to be blue. So one of these is green, one of these is blue. We don't know which. It needs a blue because otherwise it doesn't add up to each other. These are 1 through 7. No 7 here. These are 1 through 7. Oh. Okay, so this can't be 7. Well, we don't know about these. Oh, this is interesting. This has to be 9 and 8 here. So that means they must be on opposite sides. You can't have 1 or 2 with it. So that means the other one. So this must be split in half. So this must be blue, blue, and this must be green, green. Since this is blue, blue, this 2x2 area has 3 blues. So this must be green. These are green diagonally, so that must be green. These greens are diagonal, so this must be green. This 2x2 area is 3 green, so this must be blue. This 2x2 area is 3 green, so this must be blue. I have a diagonal blue, so this must be blue there. Okay, so these are boundaries. Boundary, 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 boundary. If this, even if this is green here, this would have to be blue. So this can't connect to the green this way. It must connect this way then. What else do we have? This can't be 7. So where is the 7 in column 2? It has to be here. So this is 7, which eliminates 7 in the row. It cannot be 3 or 4 here, because if it is 3 or 4, that would add up to 7. So this has to be 5 or 6 here. This can't be 1 or 2 because of the 1, 2, 3 or 1, 2, 4 triplet here to add up to 6 or 7. Okay. Blue connects to one of these, so we don't know which. One of these has to be blue, but we don't know which. One of these has to be blue. Oh, one of these has to be blue, so this is a blue-green pair, because one of them has to be green because of the cage. They still could be 2 blues here, so we don't know about that either. This is 1 digit equal to the other digit. You could actually have 7, 3, 4 here, because you could have 8, 9 as both of these cells. Huh. This can no longer be 6 because this is at minimum 1 and 3. And this can no longer be 6 also because it can't. This is at minimum 1 and 3. So same with this. No 6, no 6. Huh. So one of these is 8 or 9, the other one is 8 or 9 here. This is 2 digits equal... Okay, so this digit equals 2 digits here. So obviously this can't be 1 or 2. This cannot be 7. This adds up to 8 or 9. So this can't be 7, 6. It could be 6. Can't be 7 here. Okay. This cannot be 3 or 4. Because if it's 3 or... Well, yeah. 3 or 4 with 7 adds up to 10 at least. And 3 or 4 with 3 or 4 adds up to 7 only. That's interesting. Huh. Okay. These have to be the same digit. Okay, let's mark 5 6s. Maybe? Okay. So this is A and this is B. That means this must be B here. This must be A here. I guess we'll mark that with Z and Y. Does that help us any? Not particularly. We need to have some swap here. It cannot be 3 blues. We know that for certain because you can't have 3 digits. 7, 1, and 2 adding up to a single digit here. This can't be 1 or 2. We have 3, 4, 5, 6, 8, or 9. Oh, that's interesting. How do these interact? We know one of them adds up to 8, the other one adds up to 9. So if this is 8, this has to be 3, 5, and then this is 9 and 4, 5 there. If this is 9, and this is 8, this is 3, 5, and this is 4, 5 here. Huh. Right, because, and the reason why we know that is this cannot contain 1 or 2. This is slightly different because of this, we don't have a set here that eliminates 1 and 2 here. But this must be 1, 2, 3 adding up to 6, or 1, 2, 4 adding up to 7. Because we have to have one of these be green because of the 2 by 2 area, and then one of them must be blue because you have 3 green otherwise. So 3 of the greens add up to the blue. So therefore you have 1, 2, and 3. This can't be 1 or 2, so therefore this can't be 7 anymore. You can't have 3, 4, and 3, 4 add up to each other because that doesn't add up to 8 or 9. So if this is 8, this is 3, 5, which makes this 9, and this is 4, 5, because it can't be 3 here. If this is 9, this is 8 here, which makes that 3, 5, so then this has to be 4, 5. So either way, this is guaranteed to be 5, which means this cannot be 5. This is 6. So this is 6 and 8 here, which makes this 9 and 5 here. So this cannot be 5 here. So it can't be 3 and it can't be 4, 5. It has to be 3, 6. So this is 3, 6. So that eliminates 3 here. 3 and 6 add up to 9. So this is 9. This is 8. This is 8 then. This is 9. So this must be 4 and 5 here. Which eliminates 4 here. So this is 3 and 5. 3 eliminates 3 here. So it's 6 and 3. That's interesting. This can no longer have a 5. No 8. No 5. No 8. No 5 or 3. No 3 or 5 or 6. No 3, 5 or 6. So these add up to 8. You can't have 4 here. So this must be 7 and 1. That means this can't be 7. This is 4. That eliminates 4 here. This can't be 3. No 3. So no 7, no 1. No 1 or 7. You cannot have 2, 4 adding up to 6. You have to have 2, 3 adding up to 5. Interesting. So this is 2, 3 adding up to 5. Which means this can't be 5. That's 4. That's 5. This can't be 2. This is the 6. Which means it's the blue. So this cannot be blue. It's green. And this is 1 or 2. So 1, 2, and 3 add up to 6. So this is 3. That eliminates 3 from the rest. Oh, it's not 3 in the corners then. So no 3s in the corners. At least those. And this one. No 3 here. No 5 here. No 3 or 6. No 3 or 6. No 3 or 6. No 5. No 1. Huh. No 4, 5. No 5. Okay. Huh. No 1 here. So we have a guaranteed 1 here. These 2 digits add up to what these 2 digits are. This must have a 6 or 7. Interesting. Uh, hmm. No 5 here. So this is done here. This is done here. Okay. I guess it could be green, green, blue, green. That's possible. 2 of the blues add up to the green. So the blue, these are 2 through 7. So the green adds up to is 7 at most, which means the blue must be 2 through 5 to add up to 7. Cannot be 3 here. To add up to 7, it could be less. This is at least 4 and 1 now. And 4 and 1. So this can never be 5. Okay. So we're guaranteed a 5 here. So we're guaranteed 6 and 7 here, and then 5 here. Doesn't that mean it has to be 4? So it's 4, 7 plus 5 and 6 added together here. Because 5 cannot be here anymore, because that's 4 and 1. That's 5, plus 5 would add up to 10. Same with this. So we're guaranteed 5, 6, and 7 are in this cage. So it must to add up together. Well, that's not true. Okay, so 5 and 6 and 7 are there. You can't have 5 and 7 added together. You can't have 6 and 7 added together. You have to have 5 and 6 added together. So it's 4, 5, 6, 7. So no 1, 2, 3. This is 4, 5, 6, 7. So this is 1, 2, or 3 there. One of these is 3. That means it's with either 4, 1 or 4, 2. So one of these is guaranteed to be 3. It has to be either 4, 1 or 4, 2 to add up to 8 or 9. So one of these would be 4, so this cannot have a 4. What would the other one be, right? So this is 3. These are 3. So we have a 3 here, plus at least another 1, so that's 4. Plus... So these add up to 17, we know. 3 and 1 at minimum is 4, plus 3 is 7. So these two digits must add up to at least 10. Sorry, at most 10. Because these are at least 7. And these two digits add up to only 17 at most. Well, they add up to 17. So minus 7. 17 minus 7 is 10. So you can never have a 7 here. Well, we know this is 7, 8, and 9 here. If you have 2 and 2, it has to be 7, 8 with 6 and 9. It cannot be 7, 9 added together because two digits don't add up to that in the same row without a 7 or 9. So therefore, this must be 6, 7, 8, 9, which means this can't, that eliminates 6, 7, 8, 9 in the rest of the row. So this is 4, 5, 4, 5. That means this is 9 plus 3. 9 plus 3 is 12. 17 minus 12 is 5, which is 2 and 3. So this must be a 2, 3 pair, which means this can't be 2 or 3. This is 1. That makes this 2. So this can't be 2 anymore. This can't be 2. This has to be a 4 or 5, which eliminates 4 or 5 in the rest of the column. I'm going to pause because I'm getting a phone call. I don't know if it's something important. I'll be right back. And I'm back. Yep, we got spam. Anyways, let's continue. So this has to have... where are 6 and 7 in column 9? It has to be here. So this is 6. This must be 7. And to add up to 14, it's 1. So it's 1, 6, 7, which eliminates 1 in the column. So this can no longer be 1, this can't be 1, and this can't be 1. So this can no longer be 6 and 7 here, so 6 or 7 in column 1. One of them has to be here. So this is 6 or 7 here. So if it's 6, it could be 1 and 1, or 1 and 2. If it's 7, it's 1 and 1. Okay. Um, hmm. This can't be 9 because of 9 in the column. This can't be 9 because of 9 in the column. So again, these are 4, 7, and 5, 6. If this is a 4, 7 pair, this is 4 and this is 7. If this is a 5, 6 pair, this is 5 and this is 6. So this can't be 6 here. We have also 6, 9, and 7, 8. So if this is 7, 8, this has to be 7 and can't be 8. If this is 6, 9 here, this can't be 6 because that would force this to be 9, which is not possible. Um... So if this is 3, this would have to be 4. Which would make this 2 and 5. Can this ever be 1? No, because if this were 1, it would have to be with 6 or 7 to add up to 14. Because we don't have 8 and 9 available. So this cannot be 1, which means where's the 1 in column 1? It has to be here. So this is 1. It could be 6, 1. It could be 7, 1. It could be 6, 2. Okay, can this ever be 7 to add up to 14 now? Yes, 2, 4, and 7. Huh. Um... 7 eliminate... Oh, this can't be 7 anymore, because this can't be 7. This can't be 6. So where's the 7 in column 1? It has to be here. So then this is 7, this is 1. That adds up to 9, so this is 8. This is 9, that's 8. This can't be 1 anymore, it's 2. There's no more 1s in the row. This can't be 7, because of 7 in the row. No 7 in the row. So we have a 4, 9, 4, 9 pair in column 3, which eliminates 4 and 9 in the rest of the column. So this can't be 4, that's 7. That eliminates 7 in the rest of the row. This must be 6, that's the only place for it. This 1 here eliminates 1 here, so this is 2, which makes this 1. To add up to 9, it has to be 3 and 5. So that's 3 and 5, which makes this 2 and 4 and 2. That means this can't be 2 or 4, it's 5. This can't be 2 or 4, it's 3. That eliminates 3 here and 3 here. This 3 eliminates 3 here, so this is 2. This can't be 5, that's 4. 4 eliminates 4 here, so it's 9, which makes this 4. No more 9 here. No more 4 here. We have 2 digits adding up to the last digit. One of them definitely. So it must be 3, 5, and 8. 3, 5 adding up to 8. So this can't be 3, 5, or 8. This is 6, which eliminates 6 in the rest of the column. No 6 here, no 6 here. This can't be 6 or 9. This is a 7, 8 pair. So this must be a 6, 9 pair here. No more 2 in row 2. So this is either 2, 3 adding up to 5. 3, 4 adding up to 7, or 2, 5 adding up to 7. Okay, remaining digits in row 6. We have 1, 3, 8, 9. This can't be 1 or 9. Okay, so that's 3 or 8. This can't be 6 anymore, so this can't be 5 here. Right now, these must add up to an even sum. This can't be 4 or 5 here, so this is 2. So we have 2 here. 2 and 3 would add up to 5. But the problem is you can't have 3 or 5 here. 2 and 4 add up to 7. Sorry, 2 and 4 add up to 6, which is not possible. So it must be 2 and 5 adding up to 7. So this is 5, this is 7. This must be the blue. So this must be green to add up to it. We have a 2 by 2 area that is all... That is 3 blues, so this must be green. The blue must connect, so it must be blue that way. This is a diagonal of green, so this cannot be a diagonal of blue, so this must be green. So it's boundary, boundary, boundary. No 5 or 7 here. This is 4, so 4 and 7 add up to 5 and 6. This 7 eliminates 7 here, so it's 8 and 7. This 8 eliminates 8 here, so it's 3. That means none of these can be 3. Again, this must add up to an even number. 2 and 4 are even, 7's odd, so therefore this must be odd. So this is 1 or 9. It could be 1, 2, 4 adding up to 7. Or it's 2, 9 with adding up to 4 and 7. Remaining digits in row 4 are 1, 8, and 9. 7 cannot be here. Again, this must add up to an even amount. And this is odd, 1, 2, and 4. So this cannot be 8. This is 1 or 9. 6 eliminates 6 here. This can't be 5 anymore. 3, 4, and 6. Okay. Can this ever be 9? The answer is no, because the other 2 other digits at minimum would have to add up to 2 and 4. So this has to be 1. So since this is 1, that eliminates 1 here, 1 here, 1 here, and 1 here. We have a 2, 4 pair now in column 6, which eliminates 2 and 4 in the rest of the column. This can't be 4, this is 3, which eliminates 3 here, so that's 8. So these 2 must add up to the 8, so this must be green. Because this is green, this is a diagonal, so this cannot be blue diagonal here. So this must be green also. This is a 2 by 2 area that's all green. That's 3 green, so this can't be green. This is blue. Diagonal of blue, so this must be blue there. 2 by 2 area, that's 3 blue, which means this can't be blue. That's green. Okay, 8 eliminates 8 here, so this is 9, which means this can't be 9. That's 1. This can't be 1 or 9. This is 8. 8 eliminates 8 here, so it's 9 and 8. The 1, 2, and 4 must be green to add up to the blue 7. So green, green, this is blue. Okay. This 1 eliminates 1 here, so this has to be 1. This must be 1, 2, and 1 to add up to 4. So this is 4, 2, and 1. 2 eliminates 2 here, so it's 4 and 2. 2 also eliminates 2 here, so it's 3 and 2. 9 eliminates 9 here, so it's 6 and 9. 5 eliminates 5 here, so it's 3 and 5. We know what this is 6 and this is 4. Now we want to do the shading. The blue has to connect. And it can only connect through here. And then the green has to connect. So the green has to connect through here. And that's the shading. Oops. Oops, that's not right. And that should be it. So this is 4. Yep. Very cool, actually. Nice how the cages restricted things a lot, especially with the sums. That was the break-in was really cool, actually. Figuring that out was really awesome. Figuring out that this had to be at minimum 28, and then these were at minimum 14, so this had to be at minimum 14, which means this couldn't be just a single digit. So therefore, these had to be the same set. These had to be the same set. And because they are in the same row, and there's a 7 there, there's no way that they would have to basically form the 14 and 14. So that was a cool break-in. There's a lot of really cool stuff around here, actually. This part, which basically forced you to lose 1 and 2, which eliminated 1 and 2 there, which means this had to be 3, 4, and 5, or 6, because it couldn't be 7. That forced 7 to be there, and then this was a little interesting part where this had to be 4, 5, 3, or 3, 5, 4, no matter what. So that forced us to be 6, 8, which forced us to be 9, 5, and everything flowed from there. Very cool, actually. Very nicely, it basically flowed very well, I felt. Hard. Yeah, the logic was kind of hard. The execution I felt was much easier than a hard puzzle. Probably average difficulty execution. But the logic was, you had to come up with a logic which was interesting, right? Anyways, I hope you enjoyed this solve, and I'll see you next time on Frank Puzzles. Take care.